Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, today we will continue with new topic. Okay, which we continue with the entropy. So in my previous video lecture that I have recorded, in that video we discussed about conditional entropy and the formula. Okay, so today we will recall. So again, suppose that we have this conditional probability measure space, and we have the partition. We define a partition psi that has A1, A2, A3 until AN. So this is a finite partition. If it has these two properties, which is AI intersect AJ is equals to empty set. And number two, we have the union of AI is equals to X or the whole X. So in diagram, if we want to see the how is the partition distributed, so you have this one. So we can say this is A1, this is A2, this is A3, A5, A4, A5, and so on. So you can see that the partitions, they are disjoint, and the union of all these partition is equals to X, which is the whole X. Okay. Okay, now we have the formula for entropy. So the formula for entropy is H of psi is given by this formula. So minus of the summation from I from 1 to n of mu of AI multiplied with the log of mu of AI. Okay, remember this formula. So this is the formula of entropy. Memorize this formula. So in our case, we have that our log here, this one will be negative. So this is the value of negative. This gives you negative value. So by multiplying with the negative terms in the first term, so you will have positive. So for important remark, so for this case, we will have that the entropy of our partition psi will be positive, greater or equal to 0. So here our formula here. So this is entropy of the partition. H of psi meaning that the entropy of the partition. Okay. Okay, let's move on. Alina.
Doktor.
Ya. Ya.
Log tu ada base ke log 10?
Log saja, log. Tak ada base. Tak ada base. Yang base tu hanya untuk conditional entropy. Sekejap lagi kita discuss. Tak ada base Ni log mu AI. So this one is the entropy of the partition sahaja. So this is just a simple formula. Okay. Now we on last time also we introduced conditional entropy. Conditional entropy. So we have, let's say we have a set B, which is taken from this sigma algebra. where the measure of B is positive. Okay, if we have mu B of A, meaning that conditional measure of A with respect to B is equals to mu of A intercept B over mu B. Okay, for any A in the sigma algebra. So the measure here, we call this as conditional measure. Okay, this is the conditional measure. So we want to define the conditional entropy. So we use this formula. H of psi. So if we have a partition psi with respect to the set B, so with the given B, is equal to this formula. So by substituting this, so we will have minus of summation of I from 1 until n mu, and now we have mu here. Instead of mu, we have the base, which is B, because this is with respect to B. Mu B of A, AI, okay, multiply with the log of mu B AI. Okay, and because of that, you can substitute this measure here inside our conditional measure. So you will have minus of the summation of I from 1 until n. So mu B, mu here now B dah hilang lah sebab kita guna yang ni. So mu of AI intercept B over mu B multiply with the log of mu of AI intercept B over mu B. Is that okay?
Doktor, maksudnya kat sini sum of mu B A ni dengan log tak sama lah.
Mu B
Nilai.
A sama. Yang ni mu B A AI kan? Yang ni mu B AI sama. Sepatutnya sama.
Tak, kalau entropi, kan sum of mu AI kena equal to log mu AI kan?
This one.
Oh, dah.
This one ni apa? H of entropy partition saja. Okay. Yang ni entropy sahaja, entropy of the partition. But this one is entropy of the partition with respect to B. Maksudnya kita ada conditional entropy here. So we have given that B. Jangan confuse. Okay. So if it's conditional measure, so we have to use measure punya conditional measure lah here. The formula for conditional measure sebab ada base kat B kat sini. And by substituting it in our conditional entropy, so we have our formula is given by this. So example, you can interrupt me if you feel that I teach you a bit fast. You can interrupt me anytime, okay? Alright, so let's go for examples. Okay, let's say if you have this partition psi is given by this A1, A2 until AN. Okay. Now you have two partitions. Okay, psi and eta. So eta have B1, B2 until BM. Okay. So kita dah tahu formula for let's write. Sebab ni agak confusing kalau kita tak tulis. Okay, first I write black dulu. So H of psi, or meaning the entropy of the partition, is given by this formula. Okay. And now you have the conditional entropy, which is given that B, okay, is this formula. Mu now B AI log mu B AI. Okay, this is give you minus of summation of I from 1 to n of mu of AI. This is mu AI intersect B over mu B log of mu AI intersect B over mu B. Okay, now the third one. This is what we want to find. So this is psi with respect to eta. So now kita ada three types dah. First, entropy of partition. Next, entropy of the partition with respect to B, which is one of the, let's say eta, one of the element in eta. Now, what if we have entropy of psi with respect to eta, which means the whole eta here. Okay, ada tiga. So now, how do you write this? That means that we have to write this in average. Kalau eta ni with respect to psi, with respect to partition, another partition. Okay, so yang ni kita kena tulis in we have to take the average of the entropy. So we have the formula is this. No, tak ada negative. Okay, this one because we take the average. So the summation of I from 1 until n, mu of Bi, we multiply with the entropy of the psi partition with respect to Bi, with respect to one of the elements in the eta. So what does it mean by this formula? This means that this is the this one, the red one is the conditional entropy with respect to given elements in eta. And this meaning that we are computing the average. Contoh, BI. BI can be, kalau from eta, since here, our eta has B1, B2 until BM. So you have to find all the values, all the entropies inside this. Have to find all the entropies inside the eta. That means you have to find H psi of B1, H psi of B2 until H psi of BM, because this is with respect to eta. Okay, so we have many calculations that you need to do in order to find the conditional entropy for the case of partition with partition dengan partition. Ini partition dengan partition. Ini partition dengan element of the partition, and this one only partition. Can you differentiate so far this for this part? Any questions? No.
Doktor.
Ya. Yeah?
Masa yang kira conditional tu yang ada log
Bukan. Semua ada log macam ni. H entropy ni, entropy of ni adalah formula general biasa Boleh kan?
Bukan. Maksud saya dekat ni yang ni. Sekali ni. Bila yang nak calculate
yang ni kena ada, kalau partition ni dengan respect to element of the partition, contoh B1, you have to have log. Okay, boleh beza tak? Kalau yang ni partition, given that partition, tapi partition ni ada banyak elements kan, B1, B2, B3 until BM. So you have to find the average dulu, baru darab dengan conditional entropy dengan partition with respect to the element. So maksudnya kat sini nanti you have to find psi B1, so you have to have the log lah. Mu of A1 intercept B1, A1 intercept A2 intercept B1 and so on. Ni kena ada log. Ini kena ada log, ini kena ada log. For this one tak ada log sebab ini with respect to partition dengan partition you have to take the average dulu baru darab dengan log nanti dalam ni. Okay, kita tengok dia punya example dulu. Okay, first. Let's see. Okay, for that, let's say we have this V is X. Maksudnya V is the partition V that has X, which is the whole X lah. So this one we call it as trivial case. So the question is, what is the conditional entropy for given trivial case? Kalau trivial case, you have entropy of psi with respect to it, we given that eta becomes, so now your eta, let's say eta is X, okay, the whole X. So you will have H of psi respect to eta is equals to H of psi respect to V, because sorry. Sekejap So kalau kita with respect to trivial case, trivial case maksudnya the whole X. So entropy of psi with respect to V is equals to entropy of psi with respect to X, because V tu hanya has only one element which is X. Macam mana kita nak cari dia punya conditional measure? So for conditional measure, trivial case, I have mu of X of A, right? Because kalau conditional measure, kalau ini B, kita tulis mu B, betul tak? Tapi kalau ini X, that means kita tulis mu X. So mu X of A is equals to mu of A intersects X over mu of X. Apa maksud A intersect X? This one becomes apa? Sebab ini you got this from this one. Union. This one is become union of I from 1 until n of AI is equals to X, right? So if you intersect mu A dengan X, so what do you have?
Mu X.
Mu X ke mu A?
Mu A.
Mu A. Sebab mu A dengan mu X mana lagi kecil? Mu A kan? Kalau yang kecil intersect dengan yang besar, mesti dia akan dapat yang kecil. Bukan union, intersect. So that means you have mu of A. So mu of X is 1 because the whole X, so that means you have only mu A. Okay, So now you got the probability, the conditional measure for the trivial case. So now you can replace. So this one becomes minus of the summation of I from 1 until n mu x of ai. So you can write this in the form of log mu x of ai. Okay. So this by taking the blue ink here, which is the measure here. So I have the summation of I from 1 until n mu of ai, okay, log of mu of ai. So this is what equals to the formula of the entropy of the partition. So if you want to find the conditional measure for the case of trivial case, which is trivial case meaning that V is equals to X or the whole X, the whole partition. Tak ada partition langsung, dia maksud the whole X. So that means you can write the entropy, conditional entropy given by this formula, which is actually equals to the entropy of the partition only. Okay?
Doktor.
Ya. Yeah?
Kenapa mu yang tu mu XA tu kan mu A over mu X kan? Macam mana over mu X tu boleh cancel?
Mu X ni 1. Boleh? Okay.
Okay, boleh.
Good questions. Mu X is equals to 1. So that's why you got mu A saja. Alright. Boleh? I can, kita kalau okay, kita next. So important remark. So remark, if the conditional entropy H of psi with respect to the V or have the single element, then the conditional entropy here coincides with the original entropy, that is H of entropy of the partition. So for this remark, that means that H of psi of V, which is equals to H of psi only. And the proof, that means you have, kalau nak show, that means you have to use the previous ni lah, slide yang saya show kat previous slide. Okay. Alright, so kita go for example. Example. Let X be the set 0 until 1, the segment. And you have the partition psi is equals to this element. So you have 0 until 1 over 3, 1 over 3 until 2 over 3, and 2 over 3 until 1 over 3. Okay. Next, you have another partitions, eta, that has 2 elements, which is 0 until half, and then half until 1. Okay. Let this two part. Yeah. Sorry? Itu putus.
2 over 3 hingga 1 over 3.
Sorry. Good. 2/3 until 1. Okay, thank you. So I name this as A1, A2, A3, and I name this as B1, B2. Okay. Okay, now let's try to find the conditional entropy for this H of psi with respect to eta. So this is the entropy formula for number 3, which is you have to take the average because eta has two elements. Okay, this partition with respect to partition. So you have to use the third formula, which is the average. So I from 1 until n of mu of bi. Sebab apa bi? Sebab bi is the element of eta with respect to. Multiply with the entropy of the psi with the with respect to bi. Boleh? Okay, now if you look at the formula here, you have to find one by one. Okay, first mu bi, betul? So here you have how many elements of eta? B1 dengan B2 saja kan? Okay, so you have mu B1. Saya buat biru lah. Mu B1 is how? Mu B1 is berapa? 1/2, correct? Mu B2 is 1/2. Now, ini for first part. Okay, now you have to find the second part, which is the red one lah. This one. So you have to find entropy of psi with respect to B1 and entropy of psi with respect to B2 since you have two elements in eta. Okay, now boleh next page? Nak salin?
Boleh.
Boleh, okay. So we have the entropy of psi respect to B1 is equals to, so here we can use the formula. So here I have 3 elements in psi kan? A1, A2, A3. So you have to find minus of I from 1 until 3 because you have 3 elements. Mu, so this one mu B1 of A1. Oh, AI lah, AI. Sorry, AI. Multiply with the log of mu B1 of AI. Sebab ini formula for the psi with respect to element of the partition. Okay, so kita carilah. So mu B1 AI tu macam mana? So you have mu of B1 with A1 intersect B1 over mu B1 log mu B1 A1 intersect B1 over mu B2 mu B1 minus mu B1 A2 intercept B1 over mu B1 log mu B1 A2 intercept B1 B1 over mu B1 minus mu B1 A3 intercept B1 over mu B1 log mu B1 A3 intercept B1 mu B1. So here you have to find lah A1 intercept B1 berapa. Find the values. Okay, 1 over 3. 1 over 3 over mu B1 is 1 over 2. 1 over 3 over 1 over 2?
1 over 6.
Okay, this one 1 over 6 Okay, 1 over 6. That means this one also 1 over 6. A2 intercept B1.
Doktor dapat 2 over 3.
Mana?
1 over 2 over 1 over 2 kan?
Ni 2 over 3 ya, 2 over 3, yes. 2 over 3 lah. 2 over 3. Next one, this one is 1 over 3. And this one is 1 over 3. A3 intercept B1 is, actually kalau kita tengok, kat sini dah 2 over 3. Kat sini dah 1 over 3. And the last one should be 0. Sebab kita ambil symmetric. And then kita ambil ni kan. So kalau ini 2 over 3, sini 1 over 3 and last one should be 0. So this one you can check. So actually A3 intercept B1 is empty set. So you have this one as empty set lah. Okay. So if you write this in the values, so you have minus 2 over 3 log 2 over 3 minus 1 over 3 log 1 over 3 minus 0. Is that okay? All right. Okay, so first step. So if you simplify the formula, what do you this calculation, what do you have?
0.2764.
Okay, tapi you can write it in terms of log. Leave your answer in terms of log. So you can have log 3 minus 2 over 3 log 2. Okay, this is the answer. You can leave your answer minus 2 over 3 log 2 over 3 minus 1 over 3 log 1 over 3 is okay also. If you don't have time to simplify. As long as you get the positive values. Minus, get positive, minus, okay. Okay, now we move on to the next entropy, which is the entropy with respect to B2. So entropy of psi with respect to B2, again the same. First you find, let's say, it's easier if you find, so this one is the formula, I from 1 until n of mu B2 of AI log mu B2 of AI. Okay, again you will have 3. So I want to find mu B2 of A1 first, which is easier. Maybe you can just substitute je lah. I write warna lain. So mu B2 of A1 you will have mu of A1 intercept B2 over mu B2, which is equals to what? Mu B2 of A2, that means mu of A2 intercept B2 over mu B2. and mu B2 of A3 is mu of A3 intersect B2 over mu B2. So for this case, you will have this one 0. And this one will be 1 over 3 and this one would be 2 over 3. So here your answer, if you substitute all the values here, you will have again log 3 minus 2 over 3 log 2. So actually H entropy of psi with respect to B1 dengan entropy of psi with respect to B2, they have the same values because we take the symmetric. Kalau tengok pun kita ambil symmetric punya partition. Elements of the partition is symmetric. So mesti dia punya jawapan mesti sama. Okay, so now you found everything that you want to find. So now we substitute je lah. Substitute for the H of entropy of psi respect to eta. Again, I write the formula. So I have J from 1 until n, mu of Bj multiply with the entropy of psi respect to Bj. Okay, so here you have until 2 je, since you have only 2 partitions in eta. So I have mu B1 multiply with entropy of psi respect to B1 plus mu B2 of entropy of psi respect to B2. Is that okay? Okay, good. So mu B1 dengan mu B1 dengan mu B2 kita dah cari tadi. It's 1 over 2, right? So 1 over 2 multiply with and the values of this entropy of partition psi with respect to B1. So you have log 3 minus 2 over 3 log 2 plus another 1 over 2 multiply with the same. Simplify. So it's half, yeah?
Tak apa.
Tak ada apa. Okay, half dengan half kita tambah je, maksudnya kita darab dengan 1. So that means log 3 minus 2 over 3 log 2. Which is equals to, now I can use the properties of logarithm. So this means the log 3 minus log 2 power 2 over 3. Okay. And if you simplify more, you can have log 3 over 2 power 2 over 3. Which is equals to log 3 over 3 kuasa punca 4. Square root of 4. So it depends. So kalau you leave your answer, this also can, this one also can, this one also can. Okay. Okay, so now, yeah, any questions? Yes.
Yang daripada 1/3 log 1/3 tu simplify jadi log 3 tu macam mana?
Macam mana? Ni. This one? Ni. Ya, you nak show the calculation ke? Actually, you can bring this 2/3 kan? This one. Log 2/3 and then this is multiply dengan 2/3. So that means 2/3 log 2/3 maksudnya log 2 minus log 3, betul? And then you can simplify lah, darab dengan 2/3 pula lepas tu. And then this one minus 1/3. So log 1/3 is log 1 minus log 3. Okay, dah dapat tu darab dengan 1/3 and then you try to simplify. Kalau tak dapat macam ni pun tak apa, as long as the value of your this one is the same as this one. This one sebab yang ni dah simplify kan dah. Because after that you will use again the values that you have in the calculations to get here. Okay. So for your home task, you can try to do it. Suggest 2 partitions. So I have psi is given by this element. And eta 1, let's say this is eta 1. You have 0, 1/3. This element 1/3 until 2/3 and then 2/3 until 1. Okay, and this is eta 2, another element, so 0 and half until half and 1. Okay, so compute the conditional entropy. Entropy of psi with respect to psi eta 1 and entropy of psi with respect to eta 2. This is your home task. No need to submit to me, you just familiarize yourself with the calculations in finding the entropy. Entropy tak susah, cuma calculation dia, you have to be careful with the calculations and also the formula. Okay. Okay, next we go to the properties of the partition. Let X is sigma algebra and mu be the measure space. And we have this transformation T is measure preserving transformation. The first property, the partition psi A1, A2, AN. So if we have this partition psi, then we have the pre-image of the partition by definition is given by, saya tulis kat sini lah. Then the pre-image of the partition with respect by definition is this set, the pre-image of A1, the pre-image of A2, the pre-image of A3, and until the pre-image of AN. Okay, so kalau kita ada the properties of partition, if we have a partition and if we have a transformation T, which is the measure preserving transformation, so you can find the image, right? T of the A1, T of A2, and T of AN. And if this is a partition, then you can also find the pre-image of the partition, which means that the pre-image of A1, the pre-image of A2, the pre-image of A3, and so on. So if the image of the partition is in the partition, that means our pre-image also in the partition. The pre-image also a partition. So meaning that if psi is the partition, then the pre-image is also a partition lah. Okay, now how to show these properties? First, kita ada information yang kita ada adalah partition. Okay, so apa definition of partition? That means you have to talk about disjoint and you have to talk about the union. So how to show it is also a partition? That means the pre-image. Let's say we have pre-image of AI intersect with pre-image of AJ is equals to, so here we use the property of the pre-image. Okay. Property of the pre-image. Betul dia null. Tapi property of the pre-image, first you have to do the pre-image of AI intersect with the pre-image of AJ is actually the equals to the pre-image of the AI intersect AJ. Okay, this is important. And you have AI and AJ. Since AI and AJ are partition, so they are disjoint. So this is empty set, which implies that our pre-image is also empty set, which means that they are also disjoint lah. Okay, next properties of partition is about union. So the union of pre-image of AI. So here union from I is equals to 1 until n. Okay, is equals to, again we use the property of the pre-image. That means union of the pre-image of AI is actually equals to the pre-image of the union of AI. Okay, so the union of AI is X. So the pre-image of X is actually X. So we have proved that the pre-image is also a partition. The second property, the entropy of the pre-image of the partition is equal to the entropy of the partition. It means that entropy of the inverse is also the same as the entropy of the partition. Inverse of the partition is the same as the entropy of the partition. Okay. So how to show it? You have the formula. So you know H of the inverse pre-image of the psi is equals to the summation of I from 1 until n mu of. So now instead of mu of the partition, so we have the mu of the pre-image. Pre-image of AI multiply with the log of mu of the pre-image of AI. So what is the important property of the transformation T? T is what? T is the measure preserving transformation. Kalau measure preserving transformation, measure dia sama ke tak? Sama kan? So since, alright, since T is MPT or measure preserving transformation, then you have the summation of I from 1 until K, for example, N, I use N, is equals to mu of AI log mu of AI. So this is the same as the formula that is the entropy of the partition side. Okay. So let me repeat. So this is the properties of the partition for the case of our pre-image. Okay. So we have with major space and also the major preserving transformation. So if we have psi is a partition, then the pre-image of the partition is also a partition, and you have the for each of the element in the partition, you can find the pre-image. And they are partitioned by showing that they are disjoint and also the union is equals to X, the union of the pre-image. And we have the entropy of the pre-image of the partition must be equal to entropy of the original partition. Okay. Any questions so far? No. Alright, so just to recall what we have learned for today's class. Again, entropy, the formula for the entropy here is actually minus sum with mu of AI multiply with the log of mu of AI. Since this is AI, because we consider only the elements in the psi. Okay. And we have another, we define the conditional entropy. So here psi with respect to B, where B is the one of the elements in the another partition. Okay, so so for the conditional measure, we use mu B of AI multiply with log mu B of AI. And mu B of AI is given by this formula. And you have to find the sum of the measure. And now we consider what if the how to find the entropy with respect to partition and also partition. So since the partition, the number of partitions here is 2, m. So that means you have to do m times 2 tambah darab dengan ni. So B1, B2, B3 until Bm. So you have to find all the entropies with respect to each element in the given that. Okay, and this we take the average, which we have this formula. So we for the trivial case, For trabecuous, that means we have only single element in the partition. So that means we have V equals to X. This is equals to entropy of the conditioner of X, and we found that the entropy of the psi with respect to trivial case is actually equal to the original entropy of the partition. Okay, and we consider one example, which is psi and also eta. So psi have 3 partitions, eta have 2 partitions, and want to find the entropy of the psi with respect to the partition of eta. So in this case, you have to take the average and then find the entropy of B1, entropy of psi respect to B1 and entropy of psi respect to B2. And you can find that they have the same values since our our elements in the partition are symmetric. So that means H psi B1 must be equal to H psi B2, and we have the same values. Thus, by finding H psi B1 and B2, we can substitute in our entropy with respect to partition and partition, and we have the values here, which is positive. And these are the home tasks that you need to do, no need to submit, and then you can familiarize yourself with the calculations. Okay, I think that's all for today's class. Cepat je. Any questions?
Doktor,
Ya?
yang entropi yang ketiga tadi tu, yang hash given
Ni.
psi given eta,
Aha.
yang average tu kan, kalau
Aha.
B1 dengan B2 tu nilai dia mu B1 dengan mu B2 tu nilai dia lain, kena cari average dia lah untuk masukkan nilai.
Correct.
Okay.
Yes. So here, kalau B1, B2 ni can be anything. 0 until let's say 1/3 and then 1/3 until 1. It can be. Okay, so you have to take the average lah. You have, maksudnya sebab tu kita cari satu persatu. This one. Mu B1 maksudnya kalau case 0 until 1/3, mu B1 dia adalah 1/3. So kat sini jadi 2/3. Bukan. 1 minus, yes, 2/3. Boleh? Mu B1, mu B2 dah lain. That means H entropy of respect to B1 pun lain, respect to B2 pun lain. They will not be the same because they are not symmetric. Okay? Good questions. Any more? Okay, if not then see you on Thursday, our last class before Raya. All of you are in Kuantan ke dekat rumah?
Saya dekat kampus.
Oh ya ke? Boleh balik tak?
Syarif. Saya tak balik. Tak tahulah Syarif. Balik Syarif?
Tak balik.
Tak balik. Seriously tak balik. Sian ni Raya sini lah.
Kami nak beraya rumah doktor.
Saya pun beraya rumah makcik. Ada kot insyaAllah.
Boleh.
Okay. Okay kelas, tak apa. If there's no more questions, then I see you on Thursday. We will continue about conditional entropy, but more complicated sikit lah sebab ada join partition pula. Okay. Okay, thank you class. Thank you for your patience and also for your attention. InsyaAllah see you on Thursday. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.
Salam. Thank you, Doctor.
Okay.
Thank you, Doctor.
You're welcome.